Good morning, ladies and gentlemen. For beginning, thank you all for coming. Initially, let me introduce participants of the conference and myself. My name is Irina Loshkina. We are the first year students of Moscow Institute of Physics and Technology, as we briefly call MIPT, Department of Aeromechanics and Flight Engineering, DEFI for short. We understand that you are all busy, that's why we will try to spend as less time as possible. However, I should warn you that the conference will last until 12:10. So let's move on to the structure of our speech. Firstly, my colleagues will present you the scientific activity of the Professor Nikolai Egorovich Zhukovsky. And our point of our speech is one of the most important. It's dedicated to the Central Aerohydrodynamic Institute named after Professor Nikolai Egorovich Zhukovsky. Afterwards, Gleb Panchenko, Varvara Antonova, and me will draw your attention to the Moscow complex of Tsagi Center. Finally, Aisha Musina and Rafael Ayvazov will tell you about the Holden Russian helicopters. I would like to remark that question and answer session will be in the end of each presentation, and we'll be happy to discuss some points of our speech if you are interested in. As we studied the Department of Aeromechanics and Flight Engineering, I would like to give you some brief information about its history. The Department of Aeromechanics and Flight Engineering is one of the departments of Moscow Institute of Physics and Technology, whose specialization is the field of aeromechanics. Its campus is located in Zhukovsky, where there is everything necessary for students' life. It was founded in 1965 by academicians Khristianovich, Derednitsyn, and Belosarkovsky, and ministers of aircraft industry and education, Stoletov and Dementiev. It was aimed to increase the number of specialists who could solve problems in the field of aerodynamics and aeromechanics, and who could become valuable employees. Firstly, it was based on the Zhukovsky Scientific School, which is one of the oldest Russian scientific schools. After that, it was the one department of Moscow Institute of Physics and Technology, but it was divided into the Department of Aeromechanics and Flight Engineering and the Department of Aerophysics and Space Research. Finally, it was created the Physics School of Aerospace Technologies, which is one of the most progressive educational institutions in the field of aeromechanics. Moreover, our faculty is connected with a lot of enterprises which are interested in prospective students who can become valuable employees and who can make a contribution in developing of technologies and sciences in the field of aeromechanics. As I mentioned in the part dedicated to the faculty, one of the affiliated organizations of our department is the Central Aerohydrodynamic Institute, named after Professor Nikolai Egorovich Zhukovsky. It celebrates its centenary this year. That's why we would like to begin by a presentation of scientific activity of the Tsagi Center founder, Nikolai Egorovich Zhukovsky. I would like to invite to the stage my colleagues.
Thank you, Arina. Good morning, ladies and gentlemen. Let me introduce our team. My colleagues are Natalia Popkova and Nikita Malyovanny, and my name is Georgi Bashikashvili. We are here to tell you about the famous Russian scientist, the man who lifted Russia to the sky, Nikolai Egorovich Zhukovsky. Our presentation is divided into three parts. Firstly, you will be given some background information on his life. After that, you will hear about his scientific and research work. Finally, you will hear about memory and influence. After that, a short conclusion will be given, and we will be glad to answer your questions. Now, I pass the word to my colleague Nikita to tell you about his biography.
Thank you, Georgi. To start with, Nikolai Egorovich Zhukovsky was born on the 17th of January in 1847. He was the son of Yegor Zhukovsky, who was a communications engineer. Nikolai Egorovich attended a fourth gymnasium for men in Moscow. Completing his secondary education there in 1864, he entered the Faculty of Physics and Mathematics, where he studied mathematics. He graduated in 1868, and from 1870 he taught at the second gymnasium for women in Moscow. After 2 years teaching at the gymnasium, Zhukovsky received an invitation to teach mathematics at Moscow Technical School. From 1874, he also taught theoretical mechanics there. While he was teaching these courses, Zhukovsky was also studying for his master's degree. And in 1876, he was awarded this degree for his thesis of kinematics of a liquid. After being awarded his master's degree, A special mechanics chair was created for Zhukovsky at Moscow Technical School. Zhukovsky obtained a doctorate from Moscow University in 1882 for a dissertation of stability of motion. He worked in the university and becoming the head of the Department of Mechanics in 1886. Perhaps Zhukovsky is most famous for his researches in hydrodynamics and aeromechanics. For his work in these areas, he became known as the father of Russian aviation. Zhukovsky was considered both as theoretical and experimental aspects of the subject. His theoretical work considered on lift, high-speed aerodynamics, and vortex theory, and longitudinal and cross stability, but the complement of his work with appropriate experimental observations in every case. With this twin approach, he became the Russian pioneer on both aspects of aviation. He went on to establish an aerodynamics laboratory and to teach courses on his theories and aerodynamics. Next slide, please. In addition to his biography, we want to tell you an interesting fact about his surname. The French transliteration was used in translations of his first works. You can see it on the slide. And there were different combinations of letters, as you can see. But after 1980s Olympic Games, was used another variant, like name of the city, Zhukovsky. But nowadays French variant is used in scientific papers. That's everything I wanted to tell you about his biography. And now I'm passing the word to my colleague Georgi.
Thank you, Nikita. Let's move on to his scientific researches. Next slide, please. On the screen you can see a list of his scientific works. So, Nikolai Egorovich Zhukovsky was the first man to carry out detailed research on the airflows. He was the man who answered a very simple question: how do planes fly without flapping their wings? When he became an associate professor to the chair of applied mathematics, he was mostly interested in mathematical calculations of liquids. So he analyzed their motion in various conditions and published a research named The Motion Potential of Liquids, which became one of the key papers of theory of hydrodynamics. By 1882, after returning from Europe, he had created the basis for thesis named On the Durability of Motion, which became a vital work for establishment of Moscow water supply system. The construction workers at that time had troubles maintaining the pipes, which easily burst because of hydraulic shock. Nikolai Egorovich advised him to replace valves with taps because valves were ineffective in maintaining liquid. So after replacing valves with taps, number of bursts in water supply system greatly reduced, and it was success for him. After that, by the end of 1880s, Zhukovsky became fascinated with first human attempts to fly. He began to work on the theoretical foundation for manned flight. In 1980s, he published works named On the Theory of Flight, On Propellers with Wings, and On the Decline Angle for Airplanes. The year of 1902 was crucial in Zhukovsky's career. Next slide, please. With the help of his students, he managed to build the first wind tunnel in Russia. Due to lack of space, the 7 meters long tunnel was placed right in the lobby of university. With help of volunteers and his students, he explored how the man-made objects like kites or stuffed birds behave in tunnel, and this became a basis for the theory of spinning. Next slide, please. Zhukovsky was also the first scientist to mathematically explain the origins of lifting power. As you can see on the screen, according to Zhukovsky, the lifting power equals density of liquid multiplied by the speed of the flow on incident and speed circulation and length of current segment of wing. Next slide, please. In addition to his scientific works, you can see on the screen his famous transform. He transforms the complex space circle into airfoil. And here's the formula that does this. So this is all about his scientific works. And now I'd like to pass the word to my colleague Natalia to tell you about his memories and influence.
Thank you, Georgi. And now let's turn to the third part of our presentation. To begin with, in 1904, on the basis of his laboratory, the first Institute of Aerodynamic Research was created. It was there that Zhukovsky made his main discovery. He found the force of the lift of the wing and gave a formula for calculating this force. Thus, the calculation of any aircraft became possible. Importantly, even before the war, Zhukovsky organized aviation courses. There he began the first in the world to read the course of lectures on theoretical foundations of aeronautics. In 1918, the courses were transformed into Moscow Institute of Air Fleet Engineers, and later it was renamed into the Zhukovsky Air Fleet Academy. Moreover, in summer of 1918, Zhukovsky suggested the Soviet authorities to create a complex scientific center in Russia. So, in December the 1st of 1918, the Central Aerohydrodynamic Institute, or TSAGI for short, began its work. And Zhukovsky himself, as the most authoritative aerodynamic expert, became the chairman of the TSAGI Presidium. As a result, TSAGI has become a major center of scientific research in the field of aircraft construction. It was there that a famous Ant-25 aircraft was developed, at which Valery Chkalov made his non-stop flight to America. Also, with the direct participation of Zhukovsky, the largest aviation institution, the Moscow Aviation Institute, or MAI for short, was established. Over the course of his career, he ended up authoring more than 60 research papers. In 1920, the Zhukovsky Prize was set up for advanced research in mathematics and mechanics. A city near Moscow and a great Zhukovsky on the moon are named in his honor. So, to conclude, Zhukovsky had a huge impact on the scientific community, and thanks to him and new educational institutions, the Russian aviation sphere began to develop rapidly. That's all I wanted to say, and now I would like to pass my word to my colleague Georgi.
Thank you, Natalia. To sum up, Zhukovsky is the very important scientist whose researches let the humanity conquer the sky. His work also have a huge impact in nowadays aerodynamic sciences. So now you are free to ask your questions.
Did you have a chance to read papers of Professor Zhukovsky?
Yeah, of course we had the chance, but I don't think we used it properly.
So what paper did you read?
Maybe some pieces of it in the books about physics.
Could you please show the slide with so-called lifting power? I show you that this is the power. And please give definition of power and force. Okay?
Of course, force was meant.
So this is force, right?
Yes.
Okay, good.
Thank you for the correction.
Thank you for your presentation. It was wonderful. Now let's move on to the presentation about the Central Aerohydrodynamic Institute, and I'd like to invite to the stage my colleagues.
Thank you, Arina. Good morning, ladies and gentlemen. Thank you for coming. My name is Yaroslav Kaplan, and these are my colleagues, Anna Budnikova and Ivan Telin. And today we're going to talk about TSAGI, Central Aerohydrodynamic Institute, which is located in Zhukovsky. Next slide, please. Our presentation is divided in three parts. First of all, Anna will tell you about history of TSAGI. After that, Ivan will inform you about departments of TSAGI. And finally, I will tell you about projects developed by TSAGI. In the end, short conclusion will be given to you, and you will be able to ask your questions. Now let's move to the first part of our presentation, and I pass my word to my colleague Anna.
Thank you, Yaroslav. So, I will tell you a little bit about history of TSAGI. To start with, Central Air Hydrodynamic Institute, or TSAGI for short, was officially founded on the 1st of December of 1918 by Nikolai Zhukovsky, a pioneer of Russian aviation whose research had a great impact on the rise of Russia's aviation science. It is worth mentioning that the structure of the institute was changed several times to optimally fit the needs of national economy and successfully solve various scientific problems. The high qualification of personnel, however, and the spirit remained unchanged. Here on the picture you can see Tupolev in the center with his first plane. Tupolev was the head of the institute after Zhukovsky. Next slide, please. So before the war, TSAGI worked extensively in cooperation with design bureaus and factories to further the progress of aircraft manufacturing. Here on the slide you can see one of TSAGI's laboratories in 1928. An expansion of the experimental base was necessary, and a new complex was built near Odekh railway station in 1935. And Stakhanovo residential district built for TSAGI personnel was renamed Zhukovsky after the founder of TSAGI. Next slide, please. During the Second World War, TSAGI worked on improving flight characteristics of Soviet warplanes. Here you can see the construction of some planes NT-42 and Pil-2. Despite concentrating mainly on practical tasks in accordance with the Everything for the Victory wartime slogan, fundamental research was not ignored and was later used in scientific breakthrough in the area of supersonic flight after the war. TSAGI also had a lot to do with Soviet rocket science, and in the late 1950s and 1960s the experimental base was expanded again, and a number of gas dynamic installations, wind tunnels and laboratories was introduced. The energy base was also enhanced, and experiments with aerodynamics and flight dynamics for variable geometry wing aircraft stimulated the development of various computation methods and the institute's computing base. Next slide, please. After that, in the 1960s, TSAGI worked on the development of a new generation of frontline fighters with high thrust-to-weight ratio and maneuverability. Also, TSAGI specialists greatly contributed to the development of a new generation of passenger and transport aircraft, improving its efficiency and safety. Finally, TSAGI was granted the status of State Scientific Center in 1994, and now it has several thousand employees, over 600 researchers, including several academicians of Russian Academy of Sciences, and also over 500 PhDs. To sum up, TSAGI's contribution to science is unquestionable, and it now has a say in every single aspect of aircraft manufacturing. Its reasonable combination of practical work and fundamental research is the reason for Russian aviation to still retain its leadership in the world. So this was a brief summary of TSAGI's history. Now I'll pass my word to my colleague Ivan.
Thank you, Anna. I'd like to tell you about the main departments of TSAGI. So there are such departments as aerodynamics, flight dynamics and aircraft control, strength research laboratories, experimental facilities, perspective designing, fundamental research, hydrodynamics and aeroacoustics, information technology, experimental production facilities, instrumentation technology and metrology, and international cooperation and interaction. And my colleague Yaroslav will tell you about aerodynamics, strength research laboratories, hydrodynamics, and international cooperation. So let's start with flight dynamics and aircraft control. Next slide, please. Aircraft control have always been an area of high priority for TSAGI. The institute has introduced lots of flight simulators and control systems simulators for solving complex tasks involving dynamics of maneuverable and passenger aircraft. Site specialists use simulators for the experiments with takeoff and landing modes of passenger and experiment aircraft, and also to study dynamics and controllability of unmanned aerial vehicles. Next slide, please. Experiment facilities should be mentioned. The complex of wind tunnels and gas dynamic research installations comprises more than 60 test facilities providing flight simulations at a flow velocity of 10 meters per second, which corresponds to Mach number 25. And you can see on the slide T116 wind tunnel and T128 wind tunnel. Next slide, please. Prospective designing research into the prospects of aerospace development rests on an efficient design technology which draws upon the Institute's increasing scientific and technological solutions. The results of the optimization are used in substantiating the feasibility of new concepts and preparing wind tunnels and test bench experiments. Next slide, please. Fundamental research. Moreover, scientists hold a leading position into the realm of high-velocity flow theory. The Institute performs a wide range of research in fluid and gas mechanics. Phenomenal programs for ideal and viscous flows or the aerodynamic profiles, and also SAGI has developed the mathematics models for flows or the aerial vehicles and jet out flows. Next slide, please. One of the most important areas of the information technology supplies at SAGI is the procurement of fundamental and applied computational and experimental research in aerodynamics, aeroelastics, strength, and flight control systems for aircraft of various types. The well-known computational systems are widely used in studies. Next slide, please. It's necessary to mention that developing and manufacturing aerodynamic scale models is an important line of the Institute activity. Models measure several centimeters to large scale models that have 10 meters in dimensions and more. Next slide, please. A number of innovative facilities conforming to the world standards has been created in SAGI in order to satisfy the increasing demands of modern experiment, and you can see some of them on the slide. And that's all for my part, and I'll pass the word to my colleague Yaroslav.
Thank you, Ivan. It was really interesting. Now I'm going to tell you about projects that have been developed by SAGI. Next slide, please. Well-known fact that SAGI is involved in many spheres of aircraft construction, such as aerodynamics, strength tests, and aeroacoustics, and many others. Aerodynamics is one of the most important spheres that started development by SAGI. Each aircraft constructed in Russia tests in aerodynamics in wind tunnels in SAGI. Along with aircraft research, SAGI tests other things. For example, they research airflows made by trains. On this slide, you can see wind tunnel 101. It's one of the first wind tunnels made in SAGI, and also you can see supersonic wind tunnel 117. So, next slide, please. Moreover, SAGI is engaged in other important things, such as strength tests. Without investigating different materials' durability and fastening, it's unreal to build and create an airplane. So, SAGI engineers can carry out research made in aeroelasticity both in laboratories and in practice. For the last few years, a lot of well-known projects have been made in SAGI, such as an experimental testing of strength and aeroelasticity of the most modern aircraft built in Russia, such as Su-35, Su-57, and Sukhoi Superjet 100. Next slide, please. It's necessary to mention that using new and powerful engines has turned an aircraft noise into one of the most negative factors influencing the environment. That's why specialists from SAGI are working on the noise reduction. Lately, SAGI has carried out many researches connected with engines noise reduction. For example, specialists of SAGI took part in different projects connected with civil aviation, such as Tu-134, Tu-154, and Il-86, and many others. Next slide, please. MS-21, you can see it on the left photo. has become one of the biggest, most laborious and important projects for the last few years. And in 2017, the airplane made its first flight, and scientists and engineers of TSAGI had put a great effort to achieve it. Almost all departments of TSAGI were involved in designing and creating of new civil Russian airplane. Moreover, a big job was done by aerodynamics and aeroacoustic departments. Mass production of MS-21 will start in 2019, and we hope it will be able to compete with such airplanes like Boeing 737 MAX or Airbus 320neo. Besides, TSAGI is working on many other projects now. For example, new Russian field generation fighter Su-57 is being tested by many TSAGI departments. Next slide, please. Also, today, TSAGI successfully cooperates with more than 50 foreign companies, such as Boeing, Airbus, Embraer, NASA, and so on. For the last 15 years, TSAGI has completed more than 450 contracts with foreign companies and research centers. That's all I wanted to say you about TSAGI's projects. To sum up, TSAGI is one of the most influential and biggest research centers in the aviation area. And this year, TSAGI celebrates its 100th anniversary, and that's why we have chosen this topic for our presentation. Thank you for your attention. Now I'm able to ask your questions.
Thanks for your presentation. You mentioned that sometimes research centers use computer simulation to see how plane take off and landing. So can the computer simulation display all the features of taking off and landing?
Mostly yes, but there are there are some things that, of course, scientists should explain and research. So it's a very complex test, but for nowadays, as I know, this information is it costs practically as the natural experiment. So, like this.
Thank you for your answer.
Thank you for your presentation. It was very interesting, and I've got one question for you. What do you think about the role of TSAGI research in the Second World War?
I think TSAGI had a great impact on the success of Russia in the Second World War, because it was working on the improvement of flight characteristics, as I have mentioned. So.
Thank you for your answer.
I have one question to girl. I forgot your name. Sorry for that.
Ivan?
I have a question to the girl.
Anna.
Anna. Okay, Anna. Let's imagine you are director of TSAGI. What could you do first?
It's a good question. Thank you. I think I would first make sure that the resources are spent properly and are not wasted on several things.
So finances first, yeah?
Yes.
Good. Thank you.
Thank you for your attention, and thank you for your answers.
Thank you for informative presentation. Now we'd like to pass words to our colleagues who will tell you about the Moscow complex of TSAGI Center.
Good afternoon, ladies and gentlemen. We're glad to see you. Today we would like to tell you about Moscow Department of TSAGI, or MAGI as we briefly call it. Next slide, please. Our presentation is divided into three parts. First of all, we would like to tell you about history of MAGI and its connection with our faculty, DEFI, where we will move to the main investigation of MAGI, which are dedicated to the problems of aeroacoustics and hydrodynamics. Now, my colleague Varvara Antona will tell you about history of MAGI and its connection with our faculty.
So, thank you, Gleb. And I want to tell you some brief information about history of MAGI, and let's start from the very beginning. So, after Second World War, in 60s, civil aviation industry was in need of a reduction of the noise created by aircrafts. Next slide, please. So, in 1961, in April 28, the laboratory, or SRD, or Scientific Research Department, which is connecting with aeroacoustics, was created by the chef of Tsagi, Vladimir Mikhailovich Nesishev. It was formed by the members of Evgeny Yakovlevich Yudin's department. So the head of this department was Anatoly Grigorievich Munin. He was informal and formal head of the department, and nowadays he's a professor and the leading member of the department. Now some words about experimental equipment. Next slide, please. In 60s, experimental equipment should ensure the modeling of real acoustic processes. So by that time, there was AK-1, or acoustic camera number 1. AK-2 was put into operation in 1975, and in 1984 there was the creation of AK-13. The aviation in the 60s were turbojet like Tu-104 and turboprop like Tu-114, and it was necessary to understand how the noise created by airplanes or aircraft acts on humans. So, meanwhile, in 1965 the department was completely formed, and it had its own planning bureau, design bureau, and own computer center. So there was lots of works like publications, and some publications that were all union or international. So the decade from 1965 to 1975 was the golden century of aeroacoustics, and with some participation with the best specialists of the country, the new engines to civil aviation were created. So the noise of jet stream decreased sharply, and many planes became fully compliant to the ICAO, or International Civil Aviation Organization, noise requirements. And last, in 1992, there was a really difficult time for country and the department. The entire interacoustic community tried to ensure including the noise characteristics of the aircraft as a mandatory in the norms of airworthiness, and young people which were graduated from MIBT or MAI and came to the department quickly left it. So that's all about history, and now I want to tell you about the connection between DEFI and MAGI. So an important step was the organization in 1975 of the Department of Hydrodynamics and Aeroacoustics, next slide please, on DEFI, and also the outstanding personality of one of the members of SRD9, Efimtsov. He always attract the young researchers, especially from DEFI. So that's all about connection with our department, and I want to give my word to Gleb Panchenko, my colleague.
Thank you, Varvara. In my part of presentation, I would like to tell you about one of the biggest problems of modern aviation. The usage of high-power engines causes wide spectrum of problems. One of them is noise. It causes great discomfort for people who live near airports or work in aviation. But this is the problem which lays on the surface. If we take a look at this issue from a view of aviation constructors, we will find out that high acoustic loads reduce durability of plane, hinder stable work of board equipment, and low flow parameters. Exactly with this type of problems, Moscow Department of Tsagi is dealing with. To solve this specific issue, MAGI is provided with special equipment, acoustic chambers. Today, MAGI has 3 acoustic chambers, AC2, AC11 and RK1500, which have its own purpose For example, AC2 is an acoustic anechoic chamber is used for measurement of aircraft elements in the condition of free sound field. The measurements include jet turbulence, investigation of airframe noise and air conditioning noise. AC2 has a unique free counter-air supply which allows to investigate jet noise of bypass engines in the presence of co-flow. And now the characteristic of AC2 is the test camera allowed to simulate taking off and landing conditions. That is all for AC2. Next slide, please. Facility AC11 is capable of the following test. Determination of sound absorbing structures in RC, reverberation camera, and AC, acoustic chamber. AC11 has unique technical characteristics: wide frequency range, high dynamic range, and low level of background sound, and possibility to simulate any type of excited fields, which allows to carry out standard and not standard experiments. That is all for AC11. Next slide, please. Acoustic chamber RK1500 is a third of a position of MAGI. Acoustic reverberation chamber RK1500 is used for investigation of strength and fatigue characteristics of aircraft units under acoustic loads. It's used for test certification of aviation space units in intensive acoustic field. One of the most remarkable characteristics of this chamber is that it allows to test aircraft elements with linear dimension up to 11 meters. That is all I wanted to tell you about air acoustic. Now my colleague Varvara Antonov will tell you about one of its applications.
Thank you, Gleb. And next slide, please. To begin with, the acoustics can be applied to the construction. For example, high buildings have their own wind climate, which means that the wind is high around them, and that can cause the additional load on their constructions. And so we can't placing two high buildings near to each other because it can cause their destruction. Now some information about technical equipment. According to the open sources, the industrial department uses the following equipment: wind tunnels T5, T12 and T103. So the department constructs the modes of buildings, bridges and monuments to find out and check their aerodynamic characteristics. Now I want to tell you about T1. Next slide, please. You can see its own characteristics on the slide. It is used for determination of stationary or non-stationary aerodynamics characteristics of aircraft, ships, and to study wind oscillations of industrial structures and methods of their damping. So another wind tunnel, number T5 of Moscow Tsagi, information about it you can see on the slide, also uses now, and the capabilities of this wind tunnel are used for research and development of various airplanes in takeoff and landing models, in industrial facilities, offshore oil and gas platforms. First objects which were tested in MAGI were Tsagi building on radio streets and the sculpture of Lenin for place of Soviets. At present, such works are an important stage before the construction of high buildings or very difficult constructions or some facilities before their construction. Nowadays, it is a very important work. For example, the sculpture of worker and farm woman was tested by wind tunnels. So that's all about industrial acoustics, and now I want to give my word to Arina.
Thank you, Varvara. Your part was wonderful. Next slide, please. Now let's move on to the experimental base of the Moscow complex of Tsagi Center. It includes the experimental basing that you can see on the slide, and also you can learn its characteristics if you are interested in it represents a channel tray whose length reaches 202 meters. However, the most important information about this basin consists in possibilities which its functionality proposes to the scientific and industrial world. They can be carried out with experiments. Firstly, we should mention towing tests of models of displacement in gliding vessels in calm water or regular waves. After that, there is a chance to research hydrodynamic characteristics of seaplanes and flying boats in different conditions of water. Moreover, it can be represented with planning of emergency landing or planning of life-saving operations. Finally, it's investigative research of various hydrodynamic characteristics in different conditions of water, in cavitation or other. One of the unique features of this construction, and at the same time a technical advantage compared with other similar projects, is the modeling of direct and reverse motion of an object in liquid. This property lets scientific work is research as the resistance to the movement of submarines, of seaplanes, as with working of propellers in free water. So, as for practical use of this basin, firstly it was used in 1930 when it was created, and it was modernized in 1967 and 1978. Nowadays it is used to determine hydrodynamic characteristics of different planes, and it helps to learn something new about their characteristics. Next slide, please. Now let's move on to other projects connected with hydrodynamics, which were realized due to efforts of SAGI Center workers. So you can see on the slide jet flying boat A4C and the amphibian plane B200. You can learn its characteristics during my speech if you wanted. The developing of hydrodynamics was studied in 1930 with creation of experimental basin. After that, the interest for hydrodynamics increased in 1980 with developing of amphibian planes. For instance, the jet flying boat A4C made scientists research the algorithm for calculating the motion in irregular waves and the theory of planing. Besides, the Moscow complex of SAGI Center took part in creation of the amphibian plane B200, which is used in common needs and in life-saving operations. Moreover, Institute is working on high-speed aircraft and high-speed motion. It is also learning vacation processes, and there are a lot of projects. Obviously, we couldn't spell out all the projects connected with hydrodynamics, which were realized in the Moscow complex of SAGI because of the variety of phenomena which are observed. In conclusion, I would like to say that the contribution in developing of science and technologies of this institute is enormous, and evidently it influenced on the current state of investigations in the field of hydrodynamics. Also, it helped to improve modern qualities of engineering technologies, and it's wonderful as a part of science. I would like to give word to my colleague Gleb, who will make a conclusion.
Unfortunately, we don't have any possibility to reflect in our speech current investigation of MAGI. However, we hope we will have such possibility at the next year conference. That is all, ladies and gentlemen. We tried our best to give you a clear overview about work of MAGI, which investigation are dedicated to the problem of aeroacoustic and hydrodynamics. We do hope you found our presentation interesting, and if you have any questions, do not hesitate to ask them.
Thank you for your presentation, it was really interesting, and I have got one question. Why is this department located not in Zhukovsky and in Moscow?
Thank you for your questions. Honestly, we think that is disconnected, that first of all this department was created to work at the field of industrial aeroacoustics, so I think it is to be closer to the main construction institute of Moscow.
Thank you for your answer.
Thank you for the question.
Thank you for your great presentation, and I have a question for you. So what's the main purpose today to build such planes as B200? So it's amphibia, and what's the main purpose of this?
So thank you for your question. I'm happy to answer. Today it's used in common needs. It's really big and it's enough fast. And also it's used in life-saving operations. For example, MCS. When something happens, it can really help because it's big and it's comfortable to use it since 210 or 09. So
Thank you for your answer.
thank you for the question.
Thank you for your attention.
Very good talks, actually. My question about acoustic chambers. Could you please show one picture of it? Any picture. No, this one. Why do these walls look so ugly?
Because it's an anechoic chamber, it's designed to absorb any type of sound,
Why do you need to absorb it?
to simulate a free sound field.
Thank you.
Thank you too. If it's all, thank you for your attention.
Thank you for your presentation. Now I would like to pass words to our colleagues who will tell about withholding Russian helicopters.
Thank you, Irina. So, good afternoon, ladies and gentlemen. First of all, let me introduce my team. My colleague's name is Aisha Musina, and my name is Rafael Ivalov. Today, we are going to tell about Russian helicopters, which is a leading player in the road helicopter industry, the sole Russian rotorcraft designer and manufacturer, and one of a few companies worldwide with capability to design, manufacture, test, and service modern civilian and military helicopters. Holding company Russian Helicopters is a part of state corporation Rostec and one of the most important parts of Russian military industrial complex. Actually, 6 months ago, we went on an excursion to the Russian Helicopters headquarters in Tamilina, and that was one of the reasons why we decided to tell you about this holding company today. So, our presentation is divided into 4 main parts. Firstly, we'll tell you about the structure of a holding company. After that, some facts from biography of well-known helicopter designers will be given to you. After that, you will hear about the most interesting and fascinating helicopters which were designed by MIL and Kamov Design Bureau. Then, some information about current projects of Russian helicopters will be given to you. At the end, a short conclusion will be given and you will be able to ask your questions. So, now I'd like to pass the word to my colleague Aisha, and she will tell you about the structure of a holding company and the biography of well-known helicopter designers Mikhail Mil and Nikolai Kamov.
Thank you, Rafael. Now let's start with a brief description of the structure of Russian helicopters. The holding company consists of numerous repair and service plants, about 5 construction plants and 2 component manufacturers, which are situated all over the Russia. Moreover, Russian helicopters includes MIL Moscow helicopter plant and Kamov Design Bureau, which are probably the most important parts of Russian helicopters. They are located not far from Zhukovsky and have names of the founders of Soviet helicopter construction. And now let's speak about them. Probably all of you know these names. They are Mikhail Leontievich Mil and Nikolai Ilyich Kamov. To begin with, I will tell you about Nikolai Kamov, as he was Mil's teacher and supported him a lot. So you can see a picture of him here. And next slide, please. So Nikolai Kamov was born in 1902. During the education, he showed interest in exact sciences and aviation. Later, he even tried to join the squadron, but due to the injury of his arm, he wasn't accepted. In 1923, after graduation with honor from university, Kamov went to Moscow and started his work in Junkers plant. So, in 1920s, he started to work on airplanes and autogyros. And in 1931, he was appointed as a director of Tsagi construction brigade. Later, in 1940, he became a chief designer of a design bureau for helicopters. Nikolai Kamov died in 1973. Now let's talk about Mikhail Leontievich Mil. Mikhail Mil was born in 1909, and interesting fact is that in 1909, another well-known Russian aircraft designer, Igor Sikorsky, has made his first helicopter. In 1925, Mikhail Mil went to Siberian Technical Institute. During the education, he made his first glider and his first flight. But unfortunately, while studying at the second year, he was expelled from the institute. After that, he managed to enroll to Don Polytechnic Institute. While studying there, Mikhail Mil got an invitation from Nikolai Kamov to participate in creating the first native autogyro Kaskar-1. By the way, you can see it on this picture. After graduating from the university, Kamov helped Mil to convince the commission to let Mil to work in SAGI with the autogyros. So in 1939, he became the deputy of Kamov at special plant for construction the autogyros. And in 1964, he became a chief designer at the Special Experimental Design Bureau. And Mikhail Mil died in 1970. So that's all about biography. And now I want to give the word to my colleague Rafael, and he will tell you about the most famous helicopters.
Thank you, Aisha. So now I speak about the most fascinating helicopters which were designed by Mil and Kamov Design Bureau. To start with, let's look to the first Soviet serial helicopter Mi-1. This was a helicopter of a classic single rotor design with three blade rotor and tail rotor. Mi-1 was equipped with modified tilting head. This helicopter showed rather high maneuvering capability and the high speed of 170 km per hour. On the slide you can see main specifications of each helicopter. So the second helicopter, next slide please. The second helicopter I want to tell about is Mi-8. It is the most mass-produced helicopter in the world. It has a classic single rotor design with 5-blade rotor and 3-blade tail rotor. The first experimental modification of this helicopter made its first flight in 1961. Nowadays there are more than 93 different modifications of this helicopter, which are used in different ways. These modifications include transport, all-purpose, military, ambulance and passenger helicopters. More than 83 countries use Mi-8. So now I will tell you about the heaviest and most low-lifting helicopter in the world, Mi-12. Mi-12, or V-12 as it was officially named, was designed as a super heavy helicopter for transporting intercontinental ballistic missiles. Only 2 examples of V-12 were built. V-12 used transverse rotor system which eliminates the need of tail rotor. However, this miracle of technical thought didn't go into mass production, as by the moment it was designed there wasn't a need of it anymore. And now helicopter, next slide please. And now helicopter I want to tell about is Mi-26. It is the largest serially produced helicopter. It has a classic single rotor design with 8-blade rotor with controlled blade pitch and 5-blade tail rotor. Mi-26 made its first flight in 1977. The weight of empty Mi-26 is just 28 tons, but despite this fact it can carry up to 20 tons of payload. Now let's look at the helicopter which was designed by Kamov Design Bureau. So let's pay attention to Kat-22. It has an unusual configuration for a helicopter. The aircraft of this scheme is called gyrodyne or heliplane. This rotorcraft combines capabilities of a helicopter for vertical takeoff and landing with those of a fixed wing for cruise. Actually, Kat-22 was one of the helicopters which were tested in SAGI. Now, I would like to pass the floor to my colleague Aisha, and she'll tell you about current projects of Russian helicopters.
Thank you, Rafael. So now let's move on to the next part of our presentation and talk about current projects. The company is among the world's leaders in most promising and dynamically growing area. So Russian helicopters plans manufacture around 35% of the world's fleet of combat helicopters, around 17% of the world's of super heavy lift helicopters, and 56% of the world's fleet of medium to heavy lift helicopters. In support of these words, I want to tell you about the latest products of in the medium lift class of Russian helicopters, transport and passenger helicopter K-62. You can see it on this slide. So, engineering of the new vehicle has started in 1990, and his first flight was made only in 2016. K62 is built to a single rotor design with a multi-blade anti-torque rotor ducted into a vertical tail fin. It has a 5-bladed rotor design, enclosed tail rotor, heavy-duty wheeled landing gear, and strengthened fuselage. The airframe and propeller is made about 50% of polymeric materials. The K62 is designed for cargo transportation, medical evacuation, search and rescue operations, and also can be used for corporate purposes. This helicopter has enough competitive advantages. Firstly, it can operate in a wide range of climate and geographic conditions and in external air temperatures from -50 degrees Celsius till 45. And moreover, K62 can be operated from an airbase, oil platform, and unprepared ground areas. So now I want to pass the word to my colleague Rafael, and he will make a conclusion for our presentation.
Thank you, Aisha. To sum up, I would like to say that Russian Helicopters Holding Company is very important for Russian military-industrial complex. Russian Helicopters United main Russian Helicopter Design Bureau and plants. Moreover, Russian Helicopters created stronger relationships with foreign partners and increased their volume of equipment delivered abroad. Its products account for approximately 90% of rotorcraft market in Russia and 10% of worldwide helicopter sales. Russian Helicopters Company is one of the main participants of international aviation shows such as MAX and Paris Air Show. Nowadays, helicopters remain one of the most important parts of aviation, as they don't need long runways and it is quite easy to use them to get to distant places, which is especially important for Russian aviation due to various landscapes of our country and impossibility to get to some places by plane. So, that is the end of our presentation. Thank you for your attention. Now you are free to ask your questions.
Thank you for your presentation. It was very interesting, and I've got one question for you. What do you know about projects? Are there any projects in Russian helicopters which are trying to solve the problem of increasing the helicopter speed?
Thank you for your question. As I realize, you are asking about a helicopter which can fly at high speeds.
Yes.
As far as I know, nowadays there only one project which is developing. It's project of K62, but nowadays I think we are working on high-speed helicopters, that is I think the main field for today. It's the main problem, and it's quite necessary for aviation to develop high-speed helicopters. But I think it's more interesting to develop VTOLs. It's like planes which can land vertically.
Thank you for your answer.
Thank you for your question.
Thank you for your presentation. I have one question. So you show us a picture of a helicopter with two propellers on the wings, but we all know about CH-57. It's an American helicopter with the propellers on its head and tail. And why did in helicopters of Russia choose the construction with the propellers on its wings, not on the head and tail?
Could you please repeat the American helicopter?
CH-57, you know, it's long one with propellers on the hand and
Chinook.
yeah.
I didn't really. Thank you for your question. I didn't really follow. I didn't really look on the construction of the American helicopter, but I think there was some reasons for. I can assume that there were some reasons for this construction of MiG-12. It was designed to carry payload up to 30 tons, and probably this was made to make it more stable. And I think that the designs of American helicopter and MiG-12 are really different, and they both have unusual schemes for a helicopter. It's called transverse rotor system, and they both have their reasons for this.
Thank you for your answer.
Thank you for your question. So, thank you for your attention and your answer and your questions.
Thank you for your presentations. Now let's move on to the conclusion of our conference. We heard 4 presentations. 3 of them were connected with the Central Aerohydrodynamic Institute, named after Professor Nikolai Gorovich Zhukovsky, with the affiliated enterprise of our faculty, which celebrates its centenary in December 2018. In addition, it's the world-famous research center in the branch of aeromechanics, and where were tested all planes in Russia. Thank you for your attention, and thank you for your support, your questions during our conference. Now I'd like to pass words to Alexander Vitalyevich.
All right, so it was great entertainment, right? Actually, I was really amazed. How could you speak so good, guys? And how could you speak about something which you don't know, actually? I think you are ready to be in any kind of conferences on aviation. Few comments. Please get rid of this table, because this table is a really bad thing. You put this text on this table and try to see on this text. Forget about text. In actual conferences, there is no tables at all. You know, actually, you are going back and forth on the stage, and nothing could help you with any kind of papers. So, another thing, I would like to see more involvement of people who is not, how do you grade them? I mean, beginners and intermediate, right, level? How do you call them? Beginners and? Yeah, intermediate. Please be involved in that and give your questions and be more active. This is very good opportunity for you to try to do something in a very unusual environment. You know, you are under the press of this stupid camera, under the press of your teachers who make this, you know, notes there, RAM and so on and so forth. And this is good for you. You know, in your life you will have this pressure not only in exams but in conferences too. So, very good progress. I believe your conference is even better than in the second year student conference, which was yesterday. Very deep and interesting talks, and more activity questions, and quite good answers. So let's thanks your teachers who provide this progress. Okay, guys? And I would be very glad to be on the next conference in November. Okay.
Thank you for your inspiring speech, and thank you for your attention. We are waiting to you in our next conference in November 2018, which will be dedicated to other affiliated enterprises of our faculty. Thank you.